Welcome to today's session. So to finish up Unit 10, braking systems, we're going to have a look at kinetic energy and friction. Starting with kinetic energy, the word kinetic comes from the Greek word kinesis, meaning motion. And kinetic energy is the energy an object has due to its motion. Now, as you know, we can't destroy energy, we can only change its state. So in the example of a car driving up a hill, we're turning the chemical energy of the petrol or diesel into mechanical energy, and that mechanical energy is going to be used to push the car up the hill and give the car kinetic energy. Once the car's at the top of the hill, the energy that's actually been stored by driving the car up the hill is still there. Gravity is trying to pull that car back down. We call that potential energy. Almost like the energy has been stored at the top of the hill. As the car rolls back down, that potential energy is turned into kinetic energy as the vehicle is accelerated down the hill. It probably makes sense that two objects of the same weight, travelling at different speeds, will have different amounts of kinetic energy. The example on the left here of the blue skier starting from higher up has more potential energy because he's at a greater height, and therefore will achieve a greater speed on the way down, therefore greater kinetic energy. It probably also makes sense that the heavier an object is, the more kinetic energy it has in motion, even at the same speed as a lighter object. So in this example, the heavier skier is going to have more kinetic energy despite the fact that they're going to travel at the same speed down the ski slope. So what does this mean for our braking system? Well, as is the purpose of our braking system to convert the kinetic energy into heat energy, if we've got a heavier vehicle, it's going to need bigger brakes to cope with that extra kinetic energy. And I selected these two cars as a good example because these have almost got identical times around the Top Gear test track. But when we look at the difference in brake size, the difference is absolutely huge. And that corresponds to the actual difference in weight. The AMG Mercedes, being a heavier car, has to have bigger brakes to cope with the increase in kinetic energy. The other way of looking at this is if we increase the speed of the vehicle by double, the actual kinetic energy will increase 4 times. So even though these cars or vehicles are similar weights, the Porsche, being able to do 205 miles an hour, needs much bigger brakes to deal with the extra kinetic energy. And this doesn't take into account the fact that the van is designed to cope with a much greater load, over 500 kilos more. So to sum up, kinetic energy is an energy an object has due to its motion, and our braking system is always designed to cope with that kinetic energy as it turns it into heat. Moving on, let's look at the second thing we need to look at today, and that's the coefficient of friction. Firstly, let's deal with friction itself. And friction is force that holds back the movement of a sliding object. You get friction anywhere that two objects come into contact with one another. As an example, try rubbing your hands together fast. You'll feel your hands heat up. That's due to friction. On cars, sometimes friction is a bad thing, and we try our best to reduce it. Think about the lubrication system inside an engine, designed to reduce friction. But in terms of our brake pad and brake disc, or our braking system, we really want friction to work. We're actually using it. We're using it to slow and stop the car. We're turning that kinetic energy of the car into heat energy using friction. What I'd like you to do now is pause this video and go and complete the activity and watch the video on the BBC Bite Size page, What is Friction? There's a link in your pack. The first thing to do with friction is that, remember, friction is independent of the area of contact. So that means if a brick slides down a plank, the frictional force is the same if the brick is lying flat or even if it's standing on end. Our second point is that friction is proportional to the load or weight that presses the two surfaces together. So this means that if we've got a pile of 3 bricks, that it's going to take 3 times the amount of force to make them slide along a surface than it would with just 1 brick. And the ratio of friction to load is a constant. That constant ratio between the weight acting down on an object and the force needed to move it is called the coefficient of friction, and is actually often expressed as the Greek letter mu, the little squiggly U at the end there. Now, in the example I gave you of bricks sliding down a plank or bricks on wood, the coefficient of friction is around 0.5 mu. Now, what that means is that a force roughly equal to half the weight of the bricks is required to overcome friction and slide the bricks against a clean wooden table. So a 1 kilo brick is going to need 500 grams to make it slide across the table. 500 grams of push force, that is. So if we took the 500 grams of push force and divided by the 1 kilo weight, we find we get 0.5. That's our 0.5 mu, our coefficient of friction for brick on wood. If we double the weight of the brick, then we also double the weight or the force that we need to slide the brick along the table. So a 2 kilo brick is going to need a 1 kilo force to make it slide along the table. However, that still gives us the 0.5 mu. 0.5 mu is our constant. Our coefficient of friction is constant. So what does that mean in terms of our brakes? Well, brake pads on a cast iron disc also have a coefficient of friction. And depending on what material is used or what makeup of that material is used, we find that it will fall somewhere between 0.3 and 0.5 mu. Although the normal range is more likely to be 0.35 to 0.42 mu. And this is worked out in exactly the same way as the bricks on the table. The force needed to slide the disc against the pad divided by the clamping force clamping the pad to the disc. And finally, there is a video, again, there's a link in your pack, of a brake being tested for you to watch, and also some worksheets for you to complete in your pack. You'll find that on Teams. Thank you.